discussion on acids and bases. We're going to talk about conjugate acid base pairs. So to kind of kickstart this discussion, let us take a very simplistic example where we have hydrochloric acid that is reacting with ammonia, NH3, and it is a reversible reaction. So we show that by those arrows, as we have discussed previously, and that actually forms ammonium ion as well as chlorine ion right there. So AQ there, AQ there, right? So let us just look at something. We can look at two forward reactions in this particular reaction, right? So we can say, okay, let me write forward, and I want you to stay with me, don't lose me. Forward reactions. We can say, okay, we see that HCl actually acts is a solid. Why am I saying a solid? It's an acid, so meaning that it's going to donate a proton. So that's why it forms that Cl minus plus this proton. This is the proton it's going to to donate, right? But additionally, we also have NH3, which acts as a base because it accepts a proton. Remember, we had H3 here we have H4. So it accepts that proton to form NH4 plus. So like we mentioned, HCl is an acid and ammonia is a base, right? Cool. But then we can also look at the reverse reaction. So additionally, we can also look at the reverse reaction. So in the reverse reactions, we have your ions being converted back into your compounds, right? So this means that we can have chlorine there, ion, right? Cl minus plus the proton to form HCl, right? And then we can have ammonia going back, that ion, NH4 plus, which will donate a proton to form NH3, right? So what are you noticing? In this instant, Cl minus accepts a proton, so meaning Cl minus is a base. And here, NH4 plus donates a proton, meaning it is an acid. But then when we actually define this, there's a lot of light coming in. So we don't call it just the base, we will say it is a conjugate base. And this one is a conjugate acid. So we can rewrite our that equation that we started with, where we say HCl plus NH3 right, and then we have NH4 plus aqueous plus Cl minus, which is egg. Right, so we said that this is an acid, this is a base, and this one we just said it is a conjugate acid. And this one would be your conjugate base. So what are you noticing? That HCl will form what we call HCl with Cl minus will form what we call a conjugate acid base pair, right? And then ammonia there with the iron will form another conjugate acid base pair. Okay, that was in the short. So HCl will form a conjugate acid base pair with Cl minus, and then NH3 will form a conjugate acid pair with NH4 plus, right? Let us take maybe another example. So let us say we had a question such as this one, and they were saying to us, determine the acid base pairs or conjugate. Forgot conjugate. So it's conjugate acid base pairs for the following reaction. So it was HNO3 nitric acid reacting. So it's reacting with hydroxide there, OH minus, and then you have your forming your NO3 minus plus H2O. So you have to identify which one is an acid, which one is a base, which one is a conjugate acid, and which one is a conjugate base, right? So how do we do that? So we can say, okay, so we can say for HNO3 to essentially form into NO3, it means that it must have donated a proton. So it will be H plus plus NO3 minus. So meaning this is an acid, right? So you can, and then for OH minus to have formed into H2O, it must have accepted a proton. So meaning this is a base. So this will be H2O. So now if you've identified that nitric acid is the acid and the hydroxide is the base, it's easy to know which one is a conjugate acid and which one is a conjugate base, right? So we said this is the acid, this is the base, and now it's just going to be the opposite. This one will be the conjugate acid, the conjugate base, the conjugate base, and this one over here, the water, will be the conjugate base. So we have essentially identified them. So this one will go with this one to form an acid, a conjugate acid base pair, and this one will go with that one also to form, no, this is, I wrote, this is acid over there. So it's a conjugate acid, right? So these two form conjugate, I don't need to write this, conjugate acid base pair. The same thing with these two, right? Cool. We can also take the last example. Let's say we had NH4 plus, right? That was reacting with F minus, and they say that it formed HF plus NH3, right? So it's just a matter of identifying which one donated a proton and which one accepted a proton. So for NH4 plus to form into NH3, it must have lost a proton, because it means that we had NH4 plus, which essentially donated a proton to become NH3 plus H plus. And for this one to have become HF from here, F minus, it means it must have accepted a proton. So it's F plus that proton it accepted to form HF. So which one is an acid between this and this? So we know if it accepts a proton, it is a base, according to the Lowry-Bronsted model that we discussed in the previous lesson. If it donates a proton, it is an acid, right? So therefore, if NH4 plus is an acid, it means that NH3 is its conjugate base. Conjugate base. And if this is a, what is it, a base, it means HF is its conjugate acid. Hence, this will form a conjugate acid base pair. No, those two will form conjugate acid base, a conjugate base acid base pair. The same thing with F minus and HF, right? So I'm hoping that actually cleared if you had any misunderstanding with respect to identifying conjugate acid base pairs.